Welcome back, geometry students. We are working on the second day of Standard 1 today, which should be in Class 4. If you'd like to find that notes page, the goal would be for you to follow along as we talk through these ideas. We're going to be extending the idea of segment addition postulate and the definition of midpoint that we introduced in class previously. In fact, the intro section has problems very similar to what you're used to from yesterday. So I'm going to have you pause the video here in a minute. Your goal for each one of these 4 problems is going to be to use the information provided, but to find the missing segment length that they ask you for, as well as to practice writing those general equations and reasons in the blanks. So go ahead and pause now, and when you feel like you have that taken care of, come back and you'll be able to check your understanding from yesterday. All right, welcome back. As you can see, I have taken information from each of these problems and done a little bit of labeling, which I think is always a good strategy as you get started. This problem asks us to find the length of segment MN, right there marked with those 3 question marks, if the length of segment LN is 62. So I just showed that that distance all the way across that segment was 62. There's no mention of a midpoint, so hopefully for this first one, you went with a segment addition postulate setup, where the 2 smaller parts of the segment add together to be equal to the entire thing. If we go ahead and plug in our values, that means we're going to end up subtracting 18 from 62 to get that the length of MN as a segment is 44. For question B, we do have a midpoint, so that means we're able to show that these 2 parts of the segment are the same size, but unfortunately, they're not asking us to find the length of segment DE. We were focused on CE. So I marked this entire segment from C to E with those question marks. So if we're trying to find a relationship between what we know, CD, and what we want to know using the idea of a midpoint, that would look like this. CD, this part, is half of CE, thanks to the definition of midpoint. And so when we plug in our values, that means 12 is half of CE. You can get rid of that half if you're using algebra by multiplying by 2. Hopefully it makes sense that it takes 2 of those segments together to make up that entire CE distance. So 24 should be your answer for the length of CE. Part C is very similar. We've got a midpoint again, point G. This one flips it a little bit and tells us the length of the entire segment FH is 56. They want us to track down the length of FG, so we can write a very similar general equation. FG is the part. That's going to be equal to half of the whole segment, thanks to the definition of midpoint. And so FG is half of 56, or 28. Now, question D seems a little bit different, but we have a midpoint. O is the midpoint of MN. So that means that this segment between M and O is the same length as the one between N and O. And since they're asking us to find the length of segment ON, that's really all we need. MO and ON are equal. So that would be our general equation. That's thanks again to the definition of midpoint. And since we have that value sitting there as 9, we can just say that 9 is what segment ON is equal to. So that extra little portion there with the 13 doesn't even end up being important. Hopefully those went okay. If you struggled with those, then you might want to come into RTI and get a little bit of help with our day 1 material. But otherwise, we are moving forward to work on the idea of midpoints a little bit more today, as well as segment addition postulate too. All right, down below, we are looking at situations where we've been given a midpoint. So G is the midpoint of segment FH. That means that this segment FG is congruent or the same size as segment GH. And then we have another piece of information here that FH, the whole thing, is equal to 50. Okay, so I'm just going to underline that. 50. Our goal is to find the value of x. And so there are a couple of different ways that we can do these problems, but it's very important that you're showing your work in a way that's consistent. So the first way is to think about the fact that we just said these 2 segments should be the same length. That means we would be able to take this 3x plus 4 and we would be able to label the length of segment GH in that exact same way. Now, we can't just go about doing that without having a reason, especially since we're going to have general equations and reasons as part of our work again. So if you do that, you need to explain where that came from, even though there's not an answer blank for that. That actually came from the fact that we understand the definition of midpoint. If you didn't know what it meant for G to be the midpoint of segment FH, there's no way you would be able to move that 3x plus 4 onto the other half of that segment. Now that we have all three of these values, we know the two parts of the segment and we know the whole thing, we're able to actually write a segment addition equation even though we've been given a midpoint. So the two small portions of the segment, FG plus GH, are going to combine together to make that whole segment. So what we're really using as the reason for our general equation is that segment addition postulate. But the definition of midpoint helps us out along the way. So if we go ahead and substitute our values in, FG is equal to 3x plus 4, plus GH is also 3x plus 4, and together they make FH, which is 50. If we do some algebra, combine those two like terms, same thing here with these two constants, we end up with 6x plus 8 equal to 50, and then you can go ahead and finish out that solving. Now, as I mentioned at the beginning, that is only one way to track down the value of x. So we're actually going to do this problem a second time and show you another option, which is very similar to example B and example C up above. So if those were a little bit confusing for you when I used this 1/2 idea, you're going to be able to see that happening again in this example, but with some algebra involved. So if we only want to focus on what we know, which is this FG is equal to 3x plus 4, and FH is equal to this 50, we know that because G is the midpoint, this segment FG is half of this whole thing. So another option is for us to write our equation using that. FG is half of FH. If you don't like a half as a fraction, you could write it as a 0.5. That's true because of the definition of midpoint. So we're not using a segment addition setup here. We're just using the fact that we have a midpoint. The part of a segment when a midpoint is involved is always half of that entire distance. So when we substitute this time, FG is 3x plus 4, and that's going to be half of FH, which is 50. Well, half of 50 is pretty easy to calculate, so that just means 3x plus 4 equals 25, and then we can go about our equation solving just like we did on the other equation. We just have different values along the way, but they lead to the exact same answer. X is equal to 7. So we've got some flexibility when we have midpoints. If we're concerned with a problem where we have a part of the segment and the whole thing, you've got some options about how you handle it. But if you use this option number 1, you must label on your picture and show why. So this definition of midpoint reason has to kind of be hovering here to go along with all of your segment addition postulate work. All right, that takes us through levels 1, 2, and 3, I believe, on our scale. So we're going to move now into what some of our level 4 questions will look like. Now don't tune out, because just because it's level 4 doesn't mean it's impossible. It's actually very manageable if you've understood what we've talked about so far. We already know that parts of a segment can be added together to find the length of the whole segment. Test yourself. What's that called? Parts of a segment can be added together to find the length of the whole segment. That would be the segment addition postulate part we've been working on. And then we also know that a midpoint divides a segment into two equal, or some of your teachers might have used the word congruent, parts. So we're going to combine those two ideas together. So reading very carefully, O is the midpoint of segment MN. O is the midpoint just of this segment, MN. So we're not talking about what's happening over here between M and L. That means that these two portions have to be exactly the same size. That's our definition of midpoint. So we could take this 15, we could move it over here. If we were explaining our thinking, our reason, we would write definition of midpoint out here. I'm just going to abbreviate midpoint so that it fits. And then we have another piece of information that tells us that ln, so that's all the way along this segment, is 51. And our goal is to find the length of segment LM, right there where those 3 question marks are. If you think about what's happened so far, we've used midpoint. We still have segment addition available. And in our example so far, the segment addition postulate has just been 2 segments adding up together to make a whole segment. But we can do that with as many parts as the segment is built into. This one is made out of 3 parts. So if I was writing a general equation, it would look like LM plus MO plus ON, all 3 combine together to make LN. Now we're not being asked to write a general equation, so that's optional. We don't know LM, but we do know MO and ON are both 15, and we know that that whole segment LN has a length of 51. So we can go ahead and add those together and then subtract minus 30 from both sides. And we track down that LM is equal to 21. So very similar to what we're used to, just combining those 2 ideas together to make your way through that problem.